Hi there. Today we're going to be going over an example question of definite integration where we have a factor here, k, which is unknown and we have to solve to find it rather than just doing our usual definite integration steps. I haven't done a video yet for the method of definite integration, but this will give you an idea, obviously, of how you generally go about it without going into too much detail. So what we do first is we just treat it like normal. We look at this side of the equation and we do our integration, and then we just set all of that equal to 28 over 3. So first of all, I want to rewrite that because I don't really like having a square root in here. So we know that square root means x to the power of a half. If you weren't aware of that, look over your indices again. That's important. So we've rewritten it like that. And now I can do my integration. The integration here just means you have to do your this plus 1 and then divided by the front. So obviously a half plus 1 is 3 over 2. 2 divided by 3 over 2 is the same as 2 times 2 over 3. So that's 4 over 3 x to the power of 3 over 2. In these ones, you can leave out your plus c because with definite integration, your plus c's cancel anyway. So I just tend not to write them in. If you're doing indefinite integration, absolutely remember your plus c's. You will lose a mark if you don't have that in. Okay, so that's k1 equals 28 over 3. So we take this expression and we substitute k in instead of x, and then we take that away from this expression with 1 instead of x. So 4 over 3 k to the power of 3 over 2 minus, and that would be 4 over 3 1 to the power of 3 over 2 equals 28 over 3. If you do 1 to the power of 3 over 2, that's just 1 multiplied by 4 over 3, that's just 4 over 3. So then we get 4 over 3 k 3 over 2 minus 4 over 3 equals 28 over 3. So there's a few different ways that you can go about doing this, depending on what your preferred method of algebraic manipulation is. I'm going to go through probably the most common way of doing it, which doesn't involve factorization, which is the way I do it. So what we do first is we generally with algebraic manipulation, we move over any terms that are added or subtracted first. Obviously, we're trying to get k by itself, so that means moving this term over to this side. So we get 4 over 3 k to the power of 3 over 2 equals 28 over 3 plus 4 over 3, which is equal to 32 over 3. And then obviously you can ignore this middle section now because it's just this over here is equal to 32 over 3. Then we get rid of the thing that's multiplied by k. So because it's multiplied on this side, we divide on the other side. So that means k to the power of 3 over 2 equals 32 over 3 divided by 4 over 3, which is the same as saying 32 over 3 times 3 over 4. Obviously, you can just do that in your calculator if you want. So if you put that into your calculator, then k to the power of 3 over 2 equals 8. So then this is really where your knowledge of indices comes in useful. And if you are unsure of your knowledge of your indices, you really need to look over it, or else you're just going to get completely lost on this part. So really what k to the power of 3 over 2 means is that it's k to the power of a half and then in brackets to the power of 3. So like k to the power of a half to the power of 3. So as we know, if we have an indice outside the brackets and then an indice inside the brackets, if we're joining them together, we just multiply them together. So that would give us our 3 over 2. So we know that that's correct. So what we need to do first then is if we're cubing it on this side, that means we're going to cube root it on this side. So then k to the power of a half is the cube root of 8, which is 2. And then k to the power of half really means the square root of k. So to get rid of a square root, then we have to square on the other side. So 2 squared is equal to 4. So then that is our final answer, and you can plug that back in up here, and you can see if that does give you the correct answer, and thankfully it does. So thank you. I hope that all made sense, and good luck with your questions. Bye.